Don't forget to subscribe, comment and like. Welcome. Welcome my viewers. I want to take you through chemistry theory, paper 2. This is paper 2, the year 2022, last year. It was done in the month of December. So we want to see what the students were required to, how they were supposed to respond. Question 1. Aluminium and phosphorus form oxides with the general formula M2O3. Complete table 1 by writing the properties of the oxides. Now, aluminium oxide, phosphorus oxide. Now, we were supposed to write the structure of aluminium oxide and the bond and whether it is an acid or a base. Aluminium oxide, we know it is amphoteric, right? So first let us start the structure. Aluminium oxide, it is an ionic compound, therefore it is going to form giant ionic structure, giant ionic. The type of bond is ionic bond. Ionic bond, a bond between a metal and a non-metal. Acid or a base, it is amphoteric. Amphoteric, it has acidic properties at the same time basic properties. I hope you understand amphoteric oxides and hydroxides. What about phosphorus? Phosphorus is a non-metal, oxygen is a non-metal, so they will combine covalently. So that bond here is covalent bond. Covalent bond. What about the structure? The structure, it is a non-metal, so it is molecular. It is molecular. What about is it an acid? All oxides of nanometals, they are acidic. You should know that. Acidic. All oxides of nanometals are acidic, while all oxides of metals are basic except that of zinc, aluminium, and lead or lead. They are amphoteric. Question B. The grid below shows part of the periodic table. Use it to answer the question that follow. So we were given a grid, empty grid. But you should always know that the first square here is the atomic number 1, atomic number 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. So let us go to the question and see what the question we're asking. Give the total number of elements that can be placed in period 1. Period 1, remember, across these are periods. Down these are groups, right? So this is period 1, period 2, period 3, period 4, period 5. So how many elements can be in period 1? Period 1, it is only hydrogen and helium. So there are only 2 of them. How many elements can be placed in period 5? Period 5, we just count from here up to here. There should be 18. Just count the squares, 1, 2, 3, 4, up to 18. As simple as that, you get your half mark. The next question is, place each of the following elements in the grid. Element X, whose atomic number is 14. So you go to the grid, atomic number is 14. So this is atomic number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Therefore, X should be here. X That is atomic number 14. Simple start. Element Y with the highest fast ionization energy. Highest fast ionization energy. So this one needed somebody who has understood elements in the periodic table. So Y is helium. Why do we say helium is element Y? Helium has got only 2 electrons in the outermost energy level, and it is very stable. It does not react. So it will require a lot of energy to remove the electrons from the outermost energy level. Therefore, that is why we give Y as helium. Element Z with the lowest fast ionization energy. Remember, ionization energy decreases as the atomic size or as the number of energy levels increases, and it is very easy in group 1. So Z is here. Fast ionization energy, that we give it there. Element L, whose ion L2 minus has a electron arrangement of 8.2.8. So it means up to this point it has already gained 2 electrons. So the original is 2 to 6. That is the original. Original is 2 to 6. So what is that? Oxygen, right? So oxygen is atomic number 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is L. That is L. Element D, whose ion D2 plus has electron arrangement of 2, 8, 8. It means it has already lost 2 electrons. So initially it was 2 to 8 to 8 to 2. Once it losing 2 electrons, it becomes positively charged. So 1, 2, 3, 4. It means it was atomic number 20. So you count element D. You come to take read and check. 1, 2, 3, 18, 19, 20. Right? Sorry. This is up to here. It is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So D is here. Atomic number 20. Element R, a period 3 element that exists as monatomic gas. If it is period 3 is here, and if it exists as a monatomic, then it must be the last one, because these are the ones that are monatomic gases. So therefore this is R. Helium, argon, and these other gases, they are monatomic. They have only 1 atom, unlike chlorine, which has 2 atoms. Yes. Good. So that's how you are supposed to score simple marks in number 1. I think we have done with number 1. I have skipped Roman 4. Element Q, a halogen with the highest atomic radius. So halogen with the highest, remember they are group 7, right? So these are the halogens, but the highest atomic, then it must be the last one here. So Q was supposed to be the last one. These are halogens, group 7. The general formula of alkanols is CnH2n plus this. That's fine. Draw the structure and give the name of the alkanol with n equal to 5. So when n equal to 5, it means it is C5H 2 times 5, that is 10, 11 OH. That one is actually pentanol, isn't it? But as we can see, pentanol, that is pentanol because of 5 carbon atoms. But the first one is draw the structure. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Here it is hydrogen. That's how you are supposed to draw. This is how we draw the structure. H and then OH. And then we have another H here. And this one is what we call pentanol. So you're giving the name, the OH is in carbon number 1, therefore we call it pentan 1-ol. Pentan 1-ol, meaning that the hydroxide is in carbon number 1. Pentanol, pentan 1-ol. The table below, and give the boiling points of this. So on the grid provided, draw the graph of the boiling point against the number of carbon atoms n. So here you have been told to draw the graph of boiling point against the number of carbon. Therefore here you should have boiling point and then in the x-axis number of n. So your graph was supposed to be a straight line like that. Number of carbon atoms, boiling point. That is it. The next question, from the graph determine the boiling point of the alkanol with n equal to 5. So when n equal to 5, you are supposed to draw a dotted line to the line and then go across. And the answer will be 139. So from the graph, for you to score these marks, you must show using a dotted line here. You draw a dotted line using your ruler like that, up to where you meet the graph here, and then you go across. That's how we get 139 degrees Celsius. The boiling point of the alkanol with N2, N is equal to, is much higher than that of butane. Explain. N equal to 2, it means it has 2 carbons, and butane has 4 carbon atoms. But why is the boiling point of N, an alcohol, higher than that? It is simple. The structure of an ethanol contains hydrogen bond. Remember, hydrogen bond are stronger than weak van der Waals forces that are available in butane. Therefore, the structure of ethanol contains hydrogen bonds, which require more heat energy to break, hence high boiling point. Butane has only weak van der Waals forces, which require little heat energy to break, hence low boiling point. Uses of a fuel. Fuels are used as a solvent. Alcohol is used as a fuel. Give another use of alcohol. Alcohol is used as a solvent in the manufacture of drugs. Can also be used in the manufacture of perfume. So it was simple. Write an equation for the combustion of an alkanol with N equal to 2. N equal to 2 is ethanol. So you are supposed to write the reaction between ethanol and oxygen and then balance that equation like I have done there. Then the status you are not supposed to forget. Let us go to question Roman 3. Use the bond energies in table 3 to calculate the enthalpy change of combustion of the alkanol with N equal to 2. So ethanol burns with oxygen. So combustion of ethanol is actually the reaction between ethanol plus oxygen. So oxygen, you break it like this, which was very difficult to students, I know. So once you have this, what does it give us? It gives us carbon 4 oxide. Then write carbon 4 oxide. Carbon 4 oxide is written as C double bond O. This is how carbon 4 oxide is written. Plus water. Water is O, hydrogen, right? So because we are calculating the energy changes between the bonds, the bond breaking and the bond formation, therefore you needed to use this. Therefore, we know carbon hydrogen, we have the enthalpy change here, the energy used. Carbon we have carbon. Therefore, you should know the formula that bond breaking, it is on the left side, on the reactants, and on the right side it is bond formation. Right? So when we are calculating heat change equal to bond breaking energy plus bond formation energy. But always remember, bond formation is exothermic, bond breaking is endothermic. Those are the things you need to know. But in general, so what the bond breaking energy, when you add everything there, you will get it is 417 or 4,719 plus bond formation, which is -5,750, which will be equal to -1031 kilojoules per mole. I know where the mistakes came here. When you are after this double bond of oxygen, this one here should be multiplied times 3, because when you balance this equation, this one is times 3. From here you can see 3, right? Carbon 4, the total energy here should be twice. Why? We have the 2 moles here. What about water? 3. You must multiply times 3 everything there. That is where majority will go wrong. So carbon 348. There is only one single bond here. This plus 412 for CH. There are 1, 2, 3, 4, 5 of them. That is times 5 plus this one 360. It is only one of them, oxygen. Use the following notation, the same notation, to answer the question that follow. State what the simple stroke represents. Stroke here represents the phase boundary. While the double stroke represents the salt bridge. Write the equation for the cell reaction. The equation is 2 aluminium plus 3 red, 2 positive, which is to be aqueous, to give us 2 aluminium, 3 positive plus 3 lead, a solid. So you may be wondering how do we get this? But that is the answer for now. Give the E theta value of this. If this one is this, the E theta is this. Calculate the E theta value of the aluminiums. But we know that E theta of the cell equal to E theta of reduction minus plus E theta of oxidation. So we have been given the total cell, which is positive 1.53. Where do we get this one? It is here. Equal to reduction we have, which is this, negative 0.13, and then plus into negative y, because we know this one is negative. It is this one is a reduction. This one is oxidation, right? This should be negative always. Yeah, why negative? Because it is the one that is undergoing oxidation, so it must be more negative than the other one, than this one. It must be more negative than this one. Finally, you will find that Y equal to negative 1.66 voltage. So therefore the E theta of aluminium equal to negative 1.66 V. State one use of electrochemical cell used as a source of electrical energy. Let me hurry up because of time. State why it is necessary to add dilute sulfuric acid to water to provide water with ions. To provide water with ions, since water itself is molecular. So that was the answer. State the electrode at which oxygen is produced and give a reason. B. Why it is the electrode connected to the positive terminal, hence attract negatively charged ions. Write the equation for the formation of oxygen, and that is the reaction. That is the equation. After electrolysis, the water for 88 seconds, the volume of oxygen gas collected was 23. Determine the volume of hydrogen gas collected. But remember always, the volume of hydrogen is twice that of oxygen. The volume of hydrogen produced is twice that of oxygen. Therefore, the volume of hydrogen is 23 times 2, which equal to 46.0 centimeters cube. How do you know that? Anyone who has learned electrolysis of which method was this? Of water, you will know that that is the case. Determine the amount of current used. Determine the amount of current used. So we have been given that 1 Faraday here equal to 96,500 coulombs. That is fine. But amount of current used, we have how many Faradays here from the equation? From the equation we have 4 Faradays, 4 electrons. So we will ask 4 Faradays will be how many coulombs? So it is 4 times 96,500, and this one will give us the total of 38,600 coulombs, right? That is correct. 1 mole, because we know that 1 mole of a gas at STP or RTP, for this case RTP equal to 24,000 centimeters cube, and this one has given us 38,600 coulombs. Yeah, so we will ask 23 centimeters cube will be how many coulombs? Remember, we are talking about oxygen. So this is 1 mole of oxygen gas. So this times divided by that, we will find that it is 139.92 coulombs. But amount of current, we want current. But we know that current quantity equal to current times time. We have quantity, we have time, we want current. So 69.92 equal to 88 seconds times current I, divided by 88, divided by 88. So our current I equal to 4.204 amperes. 4.204 amperes. State it and explain how the catalysts affect rate of reaction. The catalyst speeds up the rate of reaction since it allows the activation energy, thus providing an alternative route. What about the yield of the product? It does not affect the yield of the product. It doesn't affect the yield because the catalyst is not affected. It only speeds up the reaction it only speeds up a reaction. Let me just show you the answers, because I know if I continue doing this I will take 2 hours and it will take too long. I don't want to do that. So this is what you are supposed to write. Question B. Question 4C, rate of reaction. You are supposed to draw a tangent at the point where you are given the time, like that, and then write an equation for the reaction. Remember, hydrogen peroxide, when reacting to produce oxygen, the manganese does not react, therefore it is used as a catalyst. So this is the equation. This is how you are supposed to write the equation. Using the graph, we are using the graph there, and this is what we obtained. Remember, if I go through the questions one by one, it will take 2 hours, and so I don't want that. Question 5. That is it. Oxidation property. Number 6 there. Various types of cell used to electrolysis concentration. One of them is Merkel cell. Name another cell, another type of cell used, membrane cell. So that is how the paper was looking like. Number 7, the last question. I'm just giving you the marking scheme, so as you revise for your exams, they can help you. Maybe I can do for you the mathematics part of it. Question Roman 2, I will do that for you right away. So the concentration of hydrochloric acid in the stomach is 0.01 molar. If an antacid containing aluminum hydroxide is used, calculate the mass of the antacid required to neutralize 100 centimeters cube of the stomach acid. There you needed to write the equation so that you can use the number of moles. Aluminum hydroxide, which will react with HCl in the stomach to form aluminum chloride plus 3 waters. You need to balance the equation. So once you balance the equation, but we have the concentration of the acid in the stomach, which is 0.01 molar. But we know that 0.01 molar is the number of moles in 1,000 centimeters cube. So we will find out 100 centimeters of the acid will contain what? So 100 will contain 0.001 moles. So if the moles of the acid is 0.001 and the ratio is 1 to 3, it means that the moles of aluminum, so moles, moles of aluminum hydroxide, the antacid, will be equal to 0.001 divided by 3, because this is 1. That one will give us 0.000333 moles. The question was asking us to calculate the mass of aluminum hydroxide. So how do you calculate mass? Mass go to moles times RFM. Moles of aluminum hydroxide is 0.000333 times the RFM. RFM aluminum is 27. 27 plus 16 times 3. So the total will be 78. The RFM will be 78. That one will give us 0.026 grams of aluminum the antacid. Thank you. I just take you through very fast because of time. I didn't want to take lots of time. Thank you. Subscribe. Don't forget.